second, maybe.
It is visible.
Okay. Yeah. So a very warm welcome to all of you to the day 3 session for ML study jams. And so far we have seen supervised learning. We have tried to cover classification as well as regression. We've tried to look at them from a theoretical perspective. Today, the goal for today's session is going to be, some kind of ML application, very simple, very basic implementation of classification on the Iris data set, because that is where we generally start machine learning. And also, I just wanted to talk about some of the different accuracy measures that we can deploy on our ML models to analyze how good or how bad they are. Okay. So before we begin, I believe we have some new students, so we'll just go over what we have tried to recap. No, just a small recap of what we have already gone through. So let's say recap. So first of all, again, the same old machine learning tree that is going to talk about the classical machine learning techniques. Okay. So you have your supervised learning. You have unsupervised learning. And then you have reinforcement learning. So for supervised learning, the difference between the three is that supervised learning has labels. Unsupervised learning generally does not have labels. And reinforcement learning is an entire different paradigm where we use the state, action, and reward parameters to analyze how good or how bad, one, let's say, a robot is going to work. So that comes under your AI or robotics. Talking about supervised learning, we have labels. We use labeled data, which means every data is given a description or a value at the end. So from supervised learning, we try to connect the data, which is the input X, to the output or the label Y. We try to form, or we try to discover this relation. For unsupervised learning, and before that, we have two types of supervised learning that we have talked about. One is classification, and the other one is regression. Okay, so this is already covered. And classification and regression, the only difference is that the output value for classification is going to be discrete, and for regression, it is going to be a series of continuous values. And today what we are going to do is we are going to discuss unsupervised learning. So in that, we're going to talk about, we'll talk about clustering maybe later, but just to mention, there are some techniques like clustering that is going to help us find the structure in the data that is there. So structure or relation in the data. Reinforcement learning, again, like I said, you have your state, action, and reward, and it is going to, we use it to formulate a formula or a method or an algorithm that is going to guide, let's say, a robot on its own. So what kind of decision should it take on the next step? So these are the different things. So far we have covered classification and regression. So today I actually, before we move on to clustering, I wanted to show you some ways in which you can actually implement the very basic classification technique in an algorithm. You can deploy it on your Python. So we'll do that. Before that, I guess, yeah, maybe we'll move to Spot itself. So if you are on your laptop, then please open Colab. The link is just Google Colab, and then you can click on the first link and you'll be on this page where you can click a new notebook and you'll be set. Okay. So can you guys please set up Colab and let me know if you are ready? Maybe somebody can share a link to Colab. Sauradip, if you have finished setting up, then
1 second.
Sure.
I've shared the link.
Thank you. So you guys can click on this link and it will take you to a new screen. I'll show you the step-by-step procedure. So you can click on new notebook and it is going to open up a brand new fresh one. And then you can connect. All you need is a Google account. I believe everybody has one, so it should not be an issue. Done. So once you guys are done, please mention it. Okay. Cool. Once we have some responses, then I guess we'll move to that. Yeah. Perfect. So I hope everybody's on a fresh notebook. Great. Okay. So the first thing you want to do is maybe click on connect in the top right, and it is going to create connect you to this remote server that's going to compile and run all of your Python code that we're going to be writing.
Just a minute. Hello.
Yes.
I'm interrupting. Can you please provide me the link again?
Yeah, sure. No worries.
Thank you.
So I guess most people are done, right? Okay. So if you guys remember, we used to work with Colab when we started our sessions in the month of July. Cool. So we have already, had in the month of June, sorry. So we have already had some experience understanding the UI for Google Colab, how it works, different features. And if some of you are new to it, if you've forgotten, then maybe this can be like a recap to that as well. So the first thing you want to do generally in a remote server is you want to know the version of whatever language you're using. So that is going to help you when you face an error. Let's say there's an error and you don't know how to diagnose it, and you want to ask online that, hey, I faced this particular error, and so people are going to have the first response. Okay, how can I replicate that? So to replicate an error, the way to go about it is that you need to know the version of the toolkit or the language that you're using. So we can find out the version of the Python language that we are using by this following command. Okay. So that is going to give us like Python 3.7 point whatever. So this keeps changing. On your local system, Python is going to be, I believe, 3.112 or 13 maybe. But on Colab at the moment, this is the latest like stable release. So that's the one that they have. So if you guys remember, we talked about an iris data set, right? So coming to the classification part, what we are going to do is the iris data set. For the people who are in the third year, this might feel like a repetition because I started with iris when I was teaching them as well. So yeah, your iris data set, it has 4 features. So the 4 features, I guess maybe I can show you here. Yeah. So the 4 features are, if you guys can see, your sepal length. Oops.
Sepal length, sepal width, and a petal width.
Yeah, go ahead.
Then
it's a combination of the 4. So there is your sepal length, sepal width, petal length, and petal width. Right? This is like a tongue twister almost. So that is your feature set. Now, just to recap again. So your feature set is
1 minute.
yeah,
Hello.
yeah. Go ahead.
Sorry for interruption.
Yeah, no,
Actually,
no
some
worries.
some little bit time I have lost my internet connection. Therefore, I'm in collabs, but I can't access your types is the notepad types. So how can I go to the in the next things that you have opened?
So what can you see on your screen? Could you please say?
Yes, sure.
Like, just tell me what you're seeing on the screen. Maybe I can help you with that.
Just a minute, it's sharing.
Yeah, okay.
Right now, what can I do?
So go on file on the left side.
Yeah.
File, yes. Now new notebook.
Hmm.
Yeah, that's it. It's going to show up in a minute.
Just a minute, it's loading. I so.
I guess it's your internet, yeah. You were almost there, and then you refresh, right? We're back now.
Then
Okay, so now you may want to connect. The connect button is on the right side. You click on connect. So it is going to connect you to a remote runtime where all your Python code can get executed.
okay.
So you don't really need Python on your local system. You can execute code like online using Colab. So that is a great functionality.
Okay, means in this inline, I mean in this line, I can write any Python code and it should run, right?
Yeah.
Compile.
So what you're calling a line is actually a block. Okay. So in one particular block, you can write as many statements as you may want. I don't think there's any particular limit. But what we generally try to do is we want to break it down into different groups. So for each and every single block, we might want to see an output. Like you may see, if you can just maybe stop sharing, I can explain it better.
Okay.
Yeah, cool. So like you have a block here, and right underneath that block you have an output for that particular set of code, right? So maybe if I write a couple of statements here and I want to get an output, so I can separate that into different blocks. How you can create a new block is either by executing this or by going somewhere in the middle, and you can find this plus code. You click on that and you can create as many blocks as you may want. Okay, there's also option for text. So this is like a method for commenting. It uses the markdown styling language. So yeah, I hope your doubt is clear. Okay. So moving to Eris dataset, the four features at the moment that we are going to talk about are your sepal length, sepal width, petal length, and petal width. And then ID is just the observation number. Okay, and species is the label. So if I was to demonstrate in the form of a table here, I'll be using some abbreviations. So yeah. So this is going to be your features, and these are going to be the labels. Okay, so features may, first of all, we are going to have your sepal length, then you have your sepal width, then you have petal length, petal width. And for labels, you can just call it, for this particular data set, the labels are called species. So it's a single column, a single row. Okay. So features may, this can be like your feature 1, x1, this can be x2, x3, 3, and x4. So this total thing here, yeah. So this total thing here, the blue box, if you want to say, call it that, then that is called your x. Okay. So this is your x part, which is a matrix, as you can see. Let's say we try and put in some values and say 2.4, we say 2.3.0, we say 1.8. we say 2.5, and then you have a species label. So the species label is going to be as such. Yeah. This is the one. Yeah, it's here. Okay, so also you can see the columns, right? All the different columns have a different value. Like there is setosa, and you scroll down, there is versicolor, and then there is virginica. So these are the three different labels for our particular ERIS data set. So species. So let's say this is your setosa. So your y is going to be a vector that has the values setosa, virginica, yeah, versicolor. Okay, so is there a doubt or something? Okay, fine. Yeah. And let's say we use the green box for this one. So this green box here is going to be the y. So this is going to be the y, which is the label vector, and x here is going to be a matrix. So if you guys have some experience with Excel sheets, you may have seen, right? There are a lot of values sequentially in the form of a table. So tabular data, or your, let's say, CSV file, or your JSON file, all of these can be represented as your data set when we're talking about text, or we're talking about all of these data samples. So here, what we're going to do is we're going to load the ERIS data set by default using another library called cbon. So it's very simple when we use cbon. So I'm going to be writing the code now. If my keyboard is a little too loud for you, then maybe lower the volume. Okay. So the first line here is your import cbon as SNS. So cbon here is the library that we're going to use, and it is actually a plotting and visualization library like your matplotlib. But for our case, we're not going to do too much of visualization. Our focus is to load the data set very easily. Okay, and SNS here is the alias. Like instead of having to write cbon every single time, अगर मुझे हर बार ये लिखना पड़े cbon.dataloader, cbon.load dataset, yeah, cbon.so and so visualize, plot, show, then it becomes quite difficult. Instead, we try to use small abbreviations for these library names. Okay? So you can also customize and make one, but this is like the generic one. If you ask somebody that sns.load dataset is not working, तो वो समझ जाएंगे कि हाँ, you're talking about cbon. Because like numpy के लिए there was np, if you guys remember. So let's say I wanted to load my data into a variable called ERIS. So this is how I would do that using the function. Can you tell me what is cbon? Cbon, okay. So cbon, if you Google, you'll find that it is a visualization library. Visualization मतलब जो भी data है हमारे पास में, हम उसको in the form of a graph, we want to see it, we want to add color to it, we want to see how different features, different labels, how they correlate, and if there is a relation. So visualization, I have repeated a couple of times. पिछले session में भी मैंने बोला था, like visualization generally takes up understanding the data, and visualization is a part of understanding the data. So that process takes around 80% of the time when it comes to data science or machine learning. So cbon is a great tool for that. And here I just won't be doing too much of visualization, and maybe show you one example. Okay? If active screen ta zoom kore bhalo hoy, sure, why not? Okay. If you guys have any trouble seeing or understanding, then let me know. If you want to load up ERIS. Okay. So I have written two more lines here. So first of all, your sns.load dataset, load underscore dataset. So SNS, alias for cbon, instead of writing cbon.load underscore dataset, उसके बाद फिर से कहीं पे cbon लिखना पड़े, I've used an alias. And your .load underscore dataset, so load dataset is actually a function that is going to take in a parameter, and it is going to return us whatever is written. cbon mein this function is already defined. It is the technical name in Python is a submodule. So Iris here is your variable. If you attended Devoshmita's session in the morning, then she already explained. A variable is like a container, a box where you can put any value, anything you want. So here, instead of putting one single value, I have put the entire data set. I have loaded it onto the variable called Iris. So if you wanted to visualize, let's say, your simple box here, call it variable. My variable, I'll call it Iris, and inside this I have put this entire data set. Okay, so it is stored. So you can visualize it like that. Okay. So this is your iris.head. Now let's execute it. To execute a particular block in Python in your Colab, you just have to press Shift Enter or Control Enter. Okay. So it's going to give us an output. So as you guys can see, यहाँ पे जो Kaggle पे data set था, that same data set I have loaded using just 2 or 3 lines. Okay. So instead of reading it from a file, CSV file, I have automatically loaded it from cbon, where this is already uploaded. Okay. So as you can see, the contents are the same. We have 150 data observations, and then we have your 5 such rows. So .head is actually a native function of Pandas library. If you guys completed the week 1 as per your schedule, तो उसमें Pandas नाम का there was a Kaggle course, and there you may have encountered the function .head. So .head का काम होता है पहले 5 ऐसे observations को return करना in a tabular form. Okay, so you have .head, you also have .tail, so you can use that as well. In your systems, I would recommend try writing iris.tail and then followed by parentheses like we have over here. वो लिख के उसको execute करके देखो. You'll see that the last 5 observations are being printed like this. And if Colab gives us a wonderful feature. अगर हम चाहें इसको if we wanted to beautify and we wanted to interact with the table, we could do this as well. Now, because this is head function, तो सिर्फ 5 columns आते हैं. But now if you wanted to print the entire thing, then you could have easily, specified how many you wanted to see per page. You can interact, click on values, select them as per you want. You want to filter them, you can do that as well. So Colab gives you a lot of features. Okay. So Abhi,
actually, you didn't even put the link over there, but still the dataset was available to you. How did it came?
So how that happened? Yes, it looks like magic, right? So
Yeah.
cbon already has a certain number of data set, that have been uploaded. So already वो cbon की documentation में and the source code में they've already loaded some of the data sets. So we can get some hands-on experience. Like the kind of work we are doing today, it's very simple. But if I spend most of my time just writing ki guys download it from this link, guys write csv.read या pandas.open the data frame, I write all those functions, and that can be quite time consuming. And our general purpose is not to learn how to load up data. Our purpose is to use some of machine learning. So uske liye cbon is giving us a wonderful platform where wonderful functionality where we can immediately load up the data set by just writing the keyword for it. So the keyword here is Iris. So Iris data set, actually, if you guys want to see the entire data set, it is available on Kaggle. So यहाँ से if I wanted to go in and download it, and then I would share it.
When I linked it to the
linked, sure, why not?
Actually, if I don't want to load dataset from Iris, so I want to load from different sites. So how can I do?
Okay, so Iris is not a site. Iris is a single data set. Okay. Yeah, and thank you for sharing that, Sauradeep. So you can see the list of cbon data sets. So ऐसे कई सारे data set हैं. So if you want to load something else, you can go on Kaggle and you can look at that data. If that data set is not exclusively in this particular list that Sauradeep has given us a link to, then I guess you have to use a different function for opening the CSV file, maybe load it on your system. So it's done something like this. You go here on your documents, then you click on upload, and then it gives you the option to upload and so on. Right now I don't have any CSV files on me, otherwise I could.
I'm asking that there have no API, no chance for API collection for getting data by this type of library through.
You can load any of the data sets that are inside the link that Sauradeep has given, and there are other links as well, but chances are, if you're working on new data, if you're working on data that your company has given you, it may not be linked to APIs. If in case it is, then maybe there are some API fetch functions also, but I do not have an idea about those functions. I have not used things like that. Generally what we do is we load them. We work on remote servers, so automatically there is a different method to upload and work with the data set.
Okay.
Does that answer your question? Okay. So generally this ये जो Seaborn library, all the preloaded libraries and data sets, they are going to be very small, very basic, like simple tutorial level pe. That's all. Okay. So so I said that SNS is actually your visualization library. So what we're going to do is we're going to try and visualize the data that we have here. So we're going to write series being a particular variable, and as you can see, all the different parameters here that you can put. If you want to maybe select only a particular your rows or columns, then you can do that as well. That option is also there. And your SMS.set also. So this may take some time. Okay, I'll maybe try and zoom out a little. So from the columns here, you have seen that the different features. 1 second. Yeah. So the different features are your length, width, repeated twice for sepal and petal, and you have your species. So how do these different values, how do they correlate to each other if you were to plot them on a graph? So to see that, here you can use this function that I've written, function that I've written, and the output is going to be something like this. So height 2, you can change the height. U is your species, so species based on the different numbers of your labels, you want to give a different color to each of the different values. So like Setosa ke sare values are given blue, as you can see, even on the so the different data point clusters or your pair plots, they're all based on this particular legend, like Setosa, versicolor, and virginica. So 3 different colors, your blue, orange, and green, representing each one. So you can see how the sepal length, how it correlates to your sepal width. So that plot is given over here. So just like that, you have all the different plots. So this is generally used for visualization, so you can understand how that data is going to behave. If I was to say, give you this particular data set without any visualization, you do not have any visualization technique, then it becomes quite difficult to understand. Okay, how does 5.1 generally relate with 3.5 for Setosa? So based on one metric I cannot measure, I have to do some calculations, then that is going to defeat the purpose that we are trying to use. We are trying to find a faster way of understanding how the data connects. So instead of any trial or error, first step generally is to visualize the data, see how all the different features correlate, how they correlate with each other, and that's pretty much it. On the visualization side, this is very basic, so this is how you use that. And the next part that I have talked about in the last day was dividing the data set, right? So you have your entire data set over here, and we want to divide it. So let's say, again, give me some time, I'll just draw it out. very briefly. Okay. So our data is initially divided in two sections. Okay, the first one is your X number of features and Y being the labels. Okay, so this is your labels and these are your features. So let's say if you guys knew the answer to every single question that can be, that you can see in an exam, then your own logic or intuition may not be tested. मतलब मान लो एक interview हो रहा है, there is a coding interview, and you know all the possible, like let's say there are 10 possible questions that can be asked, and you know all of them. तो उसमें तुम्हारे natural learning या natural logic application नहीं होगा. All you can do is study how this particular question hai, so this is going to be the answer. So you know the question, you know the answer. So let's say you repeat it for 10 such questions. Okay, so you repeat it for 10 such questions, you repeat it for 10 such answers. So it may not be easy to analyze how good your own logical understanding is. तुम्हारा अपना, let's say, code में implementation करना, how your own learning is, that may be difficult to analyze correctly. So in that case, what generally any teacher or professor is going to do is they are going to give you a new question that nobody has probably, or you have not worked on. So based on that, they want to analyze how good your answer is going to be. So then they can get a true sense of how good you are. Okay, how good or how bad. So when we talk about accuracy measures, or when we want to use machine learning, so ML also, we want to find out how accurate our model is. So for ML, we want to find how accurate. And if we were to give every single column here, every single row here, and every single column here, and pura ye jo data set hai, the X features, if we are going to train our model with it, then it is going to understand, okay, so if the input here is 5.0 and the next one is 2.9 and the next one is 2.2 and the last one is 1.9, then of course it has to give Setosa. So in that case, there is no learning, right? The machine itself is not learning. If else ho gaya ki, directly, like very simplistic measure that agar ye value hai, then and ye value hai, and ye hai, then give Setosa. So there is no intuition, there is no learning. So in order to avoid that, what we do is we break the data. So we break the data set into two parts. So you have unseen data. So unseen data is very important. जिस question पे तुमने कभी practice नहीं किया, कुछ नया सा है, that is going to actually give you a good challenge, right? वरना अगर like every day if you only solve for linear search, so there is nothing new that you are learning, right? So you already know how linear search works. You spend all your time learning that. You spend all your time just practicing the same thing. तो कुछ नया नहीं होगा. So your true ability is not going to be judged. So what we are going to do is we are going to create a division here. So ये दो part में हम data set को divide करना चाह रहे हैं. So this part here is going to be your X training, and this here is going to be your X testing. So the test, right? To test how good or how bad your measure is, your model is. So Y के लिए भी will do the same. So for associated values like observation number 1, इसके लिए there is a label number 1. So we break this accordingly. We don't break it कि observation number, let's say 10 के लिए I am associating label 1 with it. No, I want to break it in the same linear pattern. There should not be any changes. So similarly, you have your observation number 2 and so on. So हमारे ERIS data set में, if you have gone to the Kaggle site, you can see that there are 150 such observations. So we have an option to divide them, and the general ratio for division is like 80% will go to the training data, and the rest 20% will be used for testing. And why is training more than testing? Because it's not easy to form a connection. ये जो connection बनता है कि अगर इस तरह के values आएंगे, so I have to predict this particular label. To form this kind of connection, that if I have equals F1, I shouldn't say F1, I should say you have X1, you have X2, you have X3, तो मेरा output होना चाहिए Y1. ऐसा होना, to form this particular relation, this is the part that we are trying to find out with machine learning. So this is quite difficult. तो इसी के लिए what we want to do is we want to prioritize training. So हमारा ज़्यादातर data training में लगता है, okay? And a very small set of data is enough for testing the accuracy of our particular model. So classification में the default parameter is 80. So 80 is represented like, let's say, जो 0.8 के हिसाब से they'll measure it and they'll automatically, break the data into two parts. Okay, so similarly, you have your X train over here. So it's associated, there is a Y train. And like you have your X test, it is also going to give you a Y test. So the ratio of splitting, I hope it is clear to all of you. And हम ऐसा क्यों कर रहे हैं? Why there is a need to train and test the data as a separate splitting क्यों हो रही है? I hope you can understand that. And another thing, before we even do this kind of splitting, there is another thing that we have to do, which is this particular entire X, right? So you have to separate it from. So you have to separate it. Sorry, not from Y, from the data set. To separate X from the data set, and then Y also you want to separate. So alag variables may we want to store the features and the labels. So our first step we are going to divide is in this way. Let me show you on code. Okay. So we want to first draw which is so what I have done here is that I have actually used a function called drop. So drop is another function that you will find on pandas. Seaborn also has this implementation for drop. It is the same as pandas. So what it does is, inside here, if you have a list of features, let's say तुम्हारे इसमें से you want to drop some features, like let's say you wanted to drop sepal length and petal length, you only want to take width. So ऐसे में you can use iris.drop and then you write sepal length and petal length, so it is going to drop that, and वो तुम लिखोगे एक list के अंदर. Okay, so you can do that. And
one question actually.
Yeah, hello.
Yeah, go ahead.
Yeah, what is access here? What is access?
Oh, access here. Okay. Wow. API fetching. I also got to learn. Chalo, nice. Anyway, coming to your question, Somidhi, access here means that your like this way, your columns here. Okay. So ये सब columns हो गए. So this is your column 1, column 2, column 3, column 4. So axis 1 means कि columns के basis पे we are trying to separate. Axis 0 means that we are going to delete this particular row. So you have your row 1, row 2. So this is axis 1, and this here is axis equal to 0. Okay. So when we write axis 1, which we mean that in a matrix we are trying to remove the particular column that has the label species. So species naam ka ye jo column hai here, that particular label set, we are removing that. So all of this is excluded. Okay. And what is left is the X. So we want to do that, and we want to store it inside a new variable called X_iris. Okay.
I also have a question. On what basis are we separating the data set into train and test?
Basis in the sense like ratio, or basis in the sense like which is going to be selected?
Yeah, which is going to be selected?
It's pretty, it's linear only. Sequentially, we are trying to separate that. I think some particular like train test split functions also have the random parameter where you, instead of just taking your series of setosa, it is going to randomize. Generally, we want to randomize because another reason here is yeah. So you can see that all the first like 100 of these observations, they have the same label, which is they have two labels which are setosa and versicolor. So yes, randomization is important, and we need to randomize when we are trying to split the data. So all of these hyperparameters are there if you want to select it in a certain way, then that is also there. Sometimes people randomize the data, so that randomize by default is set to true. So if you study the API documentation for scikit-learn's, which one? Yeah, so the it is the train test split from the model selection submodule. I'll maybe provide a link to that, so you can set that parameter. It is randomized generally, especially for these sequential data where these values are not these values are arranged. So SMA, it will only take the data for setosa and versicolor, and it may not really study the last label correctly. So I hope that answers your question. Okay.
Yeah.
I have a question actually.
Yeah, go ahead.
Is the Iris dataset loaded as a pandas data frame?
I think that may have been possible, because you see some of those functions like dot head and dot load and
Yeah.
dot drop. So yeah, I guess.
But we have not even imported pandas here. How are we accessing?
Because it may be possible that your Seaborn itself may have some interlink with pandas.
Oh,
That is quite possible, right? Maybe the source code itself has an import for pandas, and they have used that same implementation here, like jo superclass and subclass ka concept of that same thing they have maybe shifted and moved here, possibly.
Oh, okay.
Maybe I'll look it up for you if you want.
Sure.
I cannot give you an affirmative answer, to be honest.
No problem.
Yeah. So as you can see, again, this is another great question. Before that, we had another great question about why and how data is being randomized. So yeah, let's say we move back to our code. So let's run that. So here you can see 150 observations, but now the shape has changed to 4, which means that earlier we had your 5 different columns, right? So we had your features ke 4 columns there, your sepal length, sepal width, petal length and petal width, and you also had species. But now, because of our drop function, we have removed and we have excluded this. So this is no longer taken in the variable x. Okay, so we want to repeat the same thing, but this time we want to exclude the feature side. Okay, so we want to exclude all of this, and we want to only keep labels. So how will we do that? Is we will selectively take a subset of the entire matrix. Let me show you how to do that. I hope shape is clear. Earlier the shape would be 150, 5. Okay. If you have any doubt, feel free to ask. So it's very simple here.
Can we not use iris dot species?
Iris dot species. Why not? But first, let me show the method. Okay. So as you can see, if we select a particular particular feature from Iris, then the last one, which is the species, all of your labels are now stored inside the variable y_Iris. Okay, and y is small because it is a vector, x is capital because it is a matrix. So what Sauradeep has said is, can we use dot species? Should work. Yeah, since it works, I believe it is from pandas itself. Because Sauradeep, you remember, right? We generally use for a single, when we want to fetch for a single column, we can use the dot submodule. So I believe there is some pandas dependency here as well. Yeah.
Okay.
Okay, so this is what your basic implementation of your pandas when you use a data set might be. Please go through the pandas course on Kaggle and please complete it properly. There are very detailed and well-structured tutorials. So the next part that we are going to do is we are going to talk about the splitting. So I've been talking about splitting and training testing so far, right? So usko implement karke dekhte hain. First, we need to import some particular functions. So scikit-learn or your sklearn, if you want to talk in the terms of code. So that is another library that is going to give us an implementation. And by implementation, I mean a very precise, very perfect and very ready to use solution for your model selection, for your metric calculation, for implementing different algorithms, like for classification, whatever algorithms we have seen, जैसे तुम्हारा decision tree regressor or your Gaussian naive Bayes theorem. Yeah, so all the different like logistic regression, linear regression, your ADA boost, your XG boost, all of that is implemented. Random forest, K nearest, K means. So jitne bhi like the most popular and the most the ones that have been in being used consistently for data science, all of those functions and modules are already written for you. So all you have to do is get a degree of theoretical understanding ki why is this function doing what it is and how is it doing what it is doing. Okay, so ye do questions hote hain. If you have that, then I believe you have the level of knowledge that you need to start with Kaggle, to start with data science. Okay, so we're going to use sklearn, and the syntax here I'm going to write it out. Okay, so this is our first function. So like we talked about training and splitting, right? Training, we talked about splitting into training and testing data set. So that comes from a submodule called model selection. So model selection is a submodule inside scikit-learn, and automatically it is going to give us all our metric key, how we should split the data, and how we are going to randomize it. So all of that is given there. Another thing we are going to need is कि हम ML कर रहे हैं, हम machine learning कर रहे हैं. So what model or algorithm we are going to use? So the classifier we are going to use today, yes, Gaussian naive Bayes. We can start with that. Okay. So that is under your naive. So this is how you import your particular algorithm. So instead of naive Bayes, if you were to write your different like submodules that are inside the sklearn source code, you can also import those models and those classifiers or regressors, and you can use them accordingly. Okay. So the last thing we need is for error metrics measurement. We need some things here. We're going to see the very basic, very simple accuracy measure. We're going to talk about it as well. Okay, so isko chala do, then you'll see a green tick on the left side. Okay, so now we talked about variables like your x underscore arrays, then you had your y underscore arrays that had your features and labels separately. Okay, so now we want to split it. Splitting ke liye, what we can do is we can use your train, test, train, and split function. So how we're going to do that is so you have your so we'll go line by line, we'll go very slow. So here what I'm doing is I'm trying to call the function train underscore test underscore split. Inside this function I'm passing two parameters. पहला है तुम्हारा feature matrix, the second one is your label vector. Okay, so your feature matrix and label vector, we are trying to we are trying to pass it into the function train underscore split train underscore test underscore split, and you have your random state set to 1. So random state, what it does is there are many ways to break down a particular data set. There is a certain degree of randomization as well, ताकि किसी भी एक तरफ overfitting या bias नहीं हो. So random state, what it will do is if you and I, we were to write the same value for random state, it is going to give us, I believe, the same value. And that happens because ये जो splitting a technique है, that we can determine or we can control. So if I say random underscore state equal to 1, then using that number, it is going to perform that splitting in a particular sense. So that is going to be the same if your random state value is same. So if you write 1, I write 1, I believe we'll get the same result. Okay. So the data will be split in the same way. And another feature about Python here that we can see is unpacking. So in Python, what you can do is you can return more than one variable at the same time. So as you guys can see here, 4 different variables are being returned, which are xtrain, xtest, ytrain, and ytest. You can name them differently, but this is the general nomenclature. Maybe put an underscore in the middle, I don't know. Depends on how you want it. But your xtrain and xtest, what these are going to be doing is this kind of splitting is going to be there. Okay, so xtrain is going to be this much of your data. So xtrain will be here. So this much of your data is xtrain. Similarly, for the different values of your xtrain, then you have xtest, and ytrain and ytest. Accordingly, they're going to be distributed. Okay. So that is there. The next thing we are going to do is we are going to see how simple it is to implement machine learning using your scikit-learn. So what we're going to do is we're going to use a variable called model, and inside this we're going to make it an object of the the class Gaussian NB. So in Python, everything is an object, so no worries there. And you have your so I've explained the first line. Now the second line, what it does is that a model is a variable which is an object belonging to Gaussian NB. A Gaussian NB is your naive Bayes theorem. Okay, and your model.fit. So this is a probabilistic measure. I have explained in the last session, I believe. What is the formula for it, how it works. You can maybe go through the links and the notes in the GitHub. Maybe that will help you clear things out if you're new. And for model.fit, what it does is whatever, when we say like, machine learning, the learning part happens using the function fit. So this fit function, we are going to put our features X and we are going to put the associated labels Y train. So this is your training data, right? Your X and Y. So the training part of the data, yani jo split hua tha, the split that we saw over here, this particular section. Okay. So this particular section here, this particular section here, this entire thing is sent into the fit function. And what it does is that it trains the object model, and this becomes your machine learning model, and it trains it on the data. So let's train it for now. It's simple. Okay. So let's say you wanted to find out what it is going to predict for newer data. So abhi tak, if you guys have noticed, then we haven't used X test, right? So this model does not know ki X test kya hai. It doesn't know what are the associated features for X test. So isko is associated labels, sorry, for X test. So in that case, this is unseen data, right? So unseen data pe we want to make predictions. Like machine learning ka kaam hi hai na, newer data pe it wants to give us the result. It wants to show us how data correlates, uske beech ka connection kya hai, is there any structure to that data. So all of these are different questions that can be answered using machine learning. So on a very simple or basic introductory level, if you wanted to form predictions, then you can use your X test. Jaise maine bola, like teacher pure saal padhaye, uske baad mein they give you a test, and those test ke questions are quite new. Ya to unke values badal dete hain, right? If you guys remember chemistry or physics, they'll give you the same kind of numerical, but they will change the value. So they want to know how well you are adapted to solving and your logical ability or reasoning. So here also our particular object model, it has no idea what X test is. Usko pata nahi. There can be a 5.0 at first, there can be a 6.1. It doesn't know. Okay. Similarly, it doesn't know that for 5.1, 6.1, 5.0, what should be the associated label. Is this kind of a flower? Is it setosa? Is it a versicolor, or is it virginica? So in that case, I believe it is the right way to make a prediction. It is the right way to analyze how good our model is. there is some more detail that goes into finding how accurate the model is, and I think I'll talk about it after we finish this code. Okay. So we have declared a new variable predictions. Again, with how easy everything is in scikit-learn, it is very easy to make these predictions. Okay, it is very easy कि हम ये model जो हमने बनाया, we made this object model, then we trained it. Now at this point here in this particular block, model already knows what the connection might be between the three different between the four different features and any of the three labels. Like क्या values आने पे what kind of prediction should it make. So uske basis pe it has made some predictions, and that we have stored in a variable called predictions. So quite simple. Okay. Now what we want to do is we want to measure accuracy. So accuracy ke liye bhi we have a function. Give us how it is. So the last two lines here. So again, we have declared a new variable accuracy, and accuracy is going to use another inbuilt function, which is your accuracy score. So accuracy score, what it is going to do is it is going to take in two parameters. It is a function that is going to take in two parameters. पहले parameter में there are the true values, जो ground truth है. Okay, so again some visualization I believe is necessary. So पहले parameter में you have let's say your accuracy score. Okay, so this has two parameters. First is your y test and second is your predictions. So here your y test is going to be the truth. Okay. Truth, or we call it ground truth also, like the reality or the true value of the data set. So why is it like this? Why do we call it the truth? Because as you can see, जो original data हमें दिया गया था, right? Let's say you work as an ML engineer, your company gives you data. You have split the data. So despite being the fact that you split the data, it is, it is a part of the original data set. So the value that you have given here is the truth. Like for x underscore test, the value or the associated label is going to be y underscore test, right? For all of these different observations. Let's say 10 ke liye there was again setosa. So yeah, this is the truth. Let's say there were values like 4.5, 4.6, 5.4, and then you have 3.2. Let's say we know, right? Like ground truth hai. We have measured this, we have made a data set. So the value is true. The value is what is there in the real life, that there is a flower that has all of these different features and it belongs to the particular label setosa. So this is the ground truth. So what are predictions now, right? So predictions on the other hand are models prediction. So models prediction meaning that these are going to give you like on untested or unseen data, right? So unseen data. So what was the unseen data? It was x test or x underscore test, whatever you want to call it. So this particular data here, this was unseen because when we used the function fit, because before this, when we used the function fit, so we only passed x underscore train and we passed y underscore train, or if you want to skip the underscore, that's okay. So ये होने के बाद में we move to the next step, right? So you have your fit. तो fit के time में when we were trying to train जो machine learning का जो learning part था during the learning phase of the model, so you had your model dot fit. So during this phase, what we did was we used only x train, so it never saw a x test, so we can use it to find out predictions. We know the correct ground truth कि असली life में मतलब real life में from the data set we know what were the true values. कि this was the true value. Okay, let's say true value was setosa, but it gave us versicolor. So we know this is a wrong prediction, right? So prediction of, let's say, I is this, so true of I is this. Yeah, so we know that this is an inaccurate measure. So similarly, we can use all the different predictions. We can analyze in terms of y test, and we can see how accurate it is. So yeah, accuracy के लिए instead of having to perform a division like number of true values or positive, or sorry, the true, positive, false, negative, which we'll talk about maybe in this session or next session. So all of those different accuracy scores, instead of having to perform those calculations by yourself, you have an inbuilt function, which is your accuracy score, and is going to take in y test, and your predictions, and going to give you an output.
Actually, why don't we use the RMS error for here?
We can use, actually, accuracy underscore is like the basic sa simple sa tarika, so I went with it.
Oh, okay.
Yeah, of course. I mean, there are many ways. So what he has just said is, so root mean square error, or your RMS. So this is another error measurement technique where you find out the absolute difference between your, let's say, this is your y truth minus y pred, and then you square it, and then you root it. Okay, so this is a very good metric for measuring errors, but this comes in much later. So because most of you here may not know much or may not have a lot of experience with machine learning, so मैं ऐसा complex सा कोई formula देके I don't want to scare you. Okay, so इसीलिए मैं एकदम simple से गया. But generally for machine learning, we want to use root mean square error only. And there are other metrics as well. We can discuss those. पहले we should complete this part. Okay, so let's say we print the accuracy. So just by doing this simple, few lines of code, maybe 10 to 12 lines of code, you have successfully written your first machine learning algorithm. It's quite simple at this stage. Of course, it is going to be more complex as you work on real life data. Okay, so just to give you some experience, and as you can see here, our model has an accuracy of 0.973684, so on. Okay, so that means that it is correct on 97% of the testing data. So by just writing this simple code, we have a model that is accurate on 97% of the new or unseen data. So we can call it the accuracy, right? But that is far from the truth. Actually, if you were to correctly analyze, हमने जिस तरह से इसको train किया है, our prediction metric, it is very simple. So if you hover over your accuracy score, you can see that this is how it works. All the different parameters is going to give you a function like this. So you have your other accuracy measures. So here you have balanced accuracy score, you have your Jaccard score, Hamming loss, 0-1 loss. These come in a little later. If you guys are interested, so you can look these up yourself. There is a lot of documentation there. So there is also code that you can run, like create your own particular. One second. Yeah, so you create your own sample data and you can test it there, how it works, and what kind of answer you may get. This for multi-label, this for single or binary label. Okay, so this is your simple accuracy measure, and you want maybe so for classification. Okay, so थोड़ा बहुत formula लिख देते हैं, कोई दिक्कत नहीं है. Classification accuracy, you have your accuracy is going to be very simple, number of correct predictions so divided by total number of predictions made. Okay, so this is the particular measure that we are using right now. Okay, so और भी बहुत सारी चीजें हैं. If you guys are interested, then you can look up logarithmic accuracy. So all of these functions are inbuilt and you can easily work with them. तुमको खुद से उतना कोड लिखने की जरूरत नहीं है. although I would suggest ki if you guys write the functions by your own self, then that is the most like in-depth way of studying machine learning. Okay, so you have a certain formula as I goes to 1 until the range n, then 2 measures for the one sample belonging to class J, should be that. Yeah. So y I of j. So y is again your prediction, and that is multiplied with the log. So यहाँ पे फिर probability comes into play. So probability is used here as well in machine learning. So this is the formula for it. It looks very complex, but once you have an understanding of what y is, so y is whether your sample I, or let's say observation I, sample I belongs to your label J or class J or not. So based on that, this is going to be either your 0 or it is going to be 1. So based on that, there is this whole formula, and P here is the probability. Probability for the same, that whether sample I is going to belong to J or not. Okay. So the range here is 0 to infinity. थोड़ा सा ज़्यादा complex हो जाएगा, उतना detail में भी नहीं जाते हैं. Okay. Another thing I wanted to talk about, because this is very fundamental and like this is a recurring theme in machine learning. The terms like true positive, true negative, and your false positive and false negative. Okay. So it उसको बोलते हैं confusion matrix. So नाम से ही confusion है, right? So let's focus on it for a bit.
This is type of sampling.
These are the types of accuracy measurement.
No, actually sampling have true, sometimes true positive, true negative.
Oh, you are asking about confusion matrix.
Yes, yes.
Oh, yes. Yeah, that is your. The end goal is to predict accuracy, but yeah, the way we do that is we take up the different samples, we check whether they are true positive, true negative, false positive. Yeah. Okay.
Some kind of statistics filling.
Yeah. Machine learning has a lot of statistical, implementations. Like machine learning back in the day, there were two main categories from which we have what we call machine learning today. Pehla tha your pattern recognition. The other one was your classical statistics. So pattern recognition has now, formed into your deep learning, computer vision, image processing, whatever we call that is actually back in the day was pattern recognition from a particular image. We have, like, let's say there is a particular face, you have your ears of an animal. Okay. So you had this particular feature inside a window. So this is going to recognize a pattern. So that is pattern recognition. And for all of these formulas, this is nothing but stats. Okay. So the best part is that you don't have to calculate it on paper. For those of you who may be a little scared कि यार ये machine learning इतनी मुश्किल चीज में कैसे आ गए हम. So don't be scared. You don't have to write things on paper. This is just like understanding how things are working. There are inbuilt functions that you can use. So on a superficial level, you will have some.
Actually, I have seen this formula in my statistics books. I have just flashly remembered that something.
Yeah, see, that's what happens. So many times what happens is first time we may hear a word or a particular like phrase or any particular keyword, we may not really register what it is all about. But as you repeat your interaction with the topic, the more you fight against it, the more you're going to have a chance of winning. So that's how it is with some things that may appear a little difficult. So that's really nice that you have some experience with it. Okay. So, okay, for confusion matrix, talking about the conceptual side, let's say we have some samples, okay? So we have samples and these have a binary classification, which means the samples can either label yes or they can label no, okay? So let's say we have our, let's say we have a predicted, right? So we have a predicted box here and then we have a ground truth. Okay, so you may remember the terms. A few minutes ago, we were talking about this. So let's say we have it this way. Yeah, let's make a box. So yeah, split it in the middle maybe. Okay. This and so let's say this is our ground truth. So ground truth, no, and you have your ground truth, yes. That in reality, from your data set, this is going to be a no or a yes. Like in the data set, was the value a no or a yes? Based on this, we also have our predictions, right? You remember your you remember your predictions variable, and then for ground truth, you may remember your y test, the labels of the uh, values from the testing data set. So let's say you have your prediction that was made was either you, no, or yes. Okay. So let's say for the values that had the ground truth no, like real life में these values gave these samples gave us the label no, and we made a prediction. Our good old model, which is this particular variable, so model which this particular object, so model has made a prediction for no correctly 50 times. Okay. But for 10 such cases, it has, instead of giving us no, it has given us yes. So those will go automatically in this column. Let me extend this right here. Okay. Okay, so now coming to the yes. Let's say in reality, or the ground truth said that y test was actually equal to yes. And in 5 such cases, instead of giving us yes, our model has given us a prediction of no. Let's say for 100 cases on yes, it has given us a check of yes. Okay, so total sampling is 165. Let's say your n was equal to 165. So these are 4 important terms that I wanted to talk about. Okay, so so your first is true positive. So here the predicted is equal to yes, and your actual or the ground truth, I'm going to write ground truth using GT. So keep that in mind. This is also yes. So these kind of observations, we call it a true positive. Okay. Similarly, 4 more values that we have here are true negative. So where we predicted a no, and the actual or the ground truth was also equal to no. So by now, I hope you have a gist where we are trying to head. Okay, so you also have your false positives, because for your even basic data analytics, maybe assignment or task that you may get in your future years, you will have to use these terms. You will have to design a confusion matrix. So you're predicted here. So false positive is about those samples that have a prediction of yes, but in real life or the ground truth, these have a value of no. Okay. And last but not the least, we also have false negatives. Where the predicted value is no, and the actual output for the ground truth as well is going to be no. Oh, sorry, it is going to be yes here because it is the opposite. Okay. So these are 4 very important terms. I will be sharing the notes as usual. It will be on the GitHub. Hopefully everybody has the link to that. So you can go and check the notes out. I'll share the code as well that we wrote today. Hopefully you guys also could learn something from today's lecture. And again, last part is that this, what you see here, this particular table or this particular matrix itself is nothing but the confusion matrix. Okay. So the name is very apt, right? Confusing to some extent. But don't worry, the more you interact with it, the more you try to play with it, set your own sample set and try to make some predictions, try to fill these columns to your own imagination and try to see, okay, how many true negatives do I have, how many false positives do I have, and so on. So the measure for accuracy here, or the formula from the confusion matrix, is going to be your true positive plus true negative divided by total sample size of n. Okay, so this will become your capital N. Yeah. So here it is going to be, so let's say total positive we have here is your predicted yes, actual yes, predicted yes, actual yes. Yes, so here you have 100, and then you have your true negative, right? So the predicted is no and actual is also no. So we have 50 such values. And as you guys may be able to figure out, the total sample size is 165. So we have 150 divided by 165. Somebody tell me the decimal for this, please. Somebody please respond with the decimal.
0.91.
So nice. So 0.91. So for, let's say, this particular sample set, we can conclude that we have achieved an accuracy of 0.91, or this is going to be equivalent to 91%. Okay. So I hope accuracy is a little clear to you guys. There are also other concepts like area under the curve. There is sensitivity, specificity, but I guess on the level that you guys are, अभी उतना ज़्यादा stress out नहीं करते हैं उस पे. Slowly and slowly we're going to proceed with this. Hopefully you guys get to learn, and hopefully you complete your Kaggle courses on time, because we don't have a lot of time. We have, I think, less than 3 weeks left. Okay. So do you guys have any doubt?
Hello.
Yeah.
भैया
Hmm.
रैंडम ट्रेन टेस्ट स्प्लिट में रैंडम टेस्ट 1 और 0 कब कब रखें? मतलब टेबल में कभी देखें कि कुछ केसेस में 0 रखा है.
अच्छा, तुम रैंडम स्टेट के बारे में बोल रहे हो?
हाँ.
Okay, random state you can keep 42 as well. तो ऐसा कोई restriction नहीं है. So you keep it 42, तो इसमें दिखा रहा है that it is 100% correct model, because inaccuracies है. You can also write it as 2. ऐसा कोई, there is no restriction. The thing is कि तुम जब भी ऐसा नंबर देते हो 1 or 2 or 0 or 42, 50 जो भी, so it is going to split the data set in a particular manner. So whenever you write that particular number, you can replicate the same way of training. Okay. So whenever I write 2, the data is going to be split in a different way. So let's say 42 के time में. So now you can see, because the data was split in a different way, and वो अलग splitting के हिसाब से it was trained. So now it is giving me a different accuracy. Okay. So we'll also talk about how to counter and measure the true way, how the factual accuracy of your model very soon. Abhi ke liye just try to maybe write this code on your own, maybe implement it.
भैया और ट्रेन टेस्ट क्या?
What?
और बता देंगे प्लीज. ट्रेन एंड टेस्ट बता देंगे.
Oh, sure, why not? So let's say you're okay for train and test. Again, I'll draw it. कोई issue नहीं है. Let's say this was your data set. Originally, data set had your features here, and you had your labels here, and you wanted to split the data. So test and train, what it will do is, ये जो train section है, this will be used to fit inside a model. So let's say your model is here, okay. Okay, so your training data. Training data goes here. Training data is fed into the model to train the data. Okay. So after this we have, जैसे मैंने last day भी बोला था, after this training is over, we have a trained model. Okay. So on this trained model, इसमें हम लोग send करते हैं testing data. So we can get predictions from here. So based on these predictions, we can measure the accuracy. Okay. Because you have the actual or the ground truth, and then you have these predictions. So you can compare key ground truth ke against me, which all predictions were correct and which was wrong. So based on that, you can have a number of correct and you can have number of wrongs. So based on that, like I have explained over here, you can use a very simple formula, like number of correct predictions divided by number of predictions made in total, like जो testing data का size था. So this will be your end test. Okay. So based on this, you can measure your accuracy. So is it clear now? The test or train क्या है?
Yes.
Okay. Does anybody else have a doubt? Okay. Okay. So I believe since you guys don't have any doubts, we can conclude today's session. Thank you so much everyone for joining. And if you have any doubts, maybe check out the GitHub once. I'll upload the notes in a couple of days. So you can use that. I'll upload the code as well in the form of a Jupyter Notebook file, and you guys go through that. And hopefully, if you have any doubts, then there is a discussion panel on the GitHub as well, where you can ask all your doubts. So, and I generally respond in a day or two. So please be interactive. The ML study jams, it is like, we are trying to cover the very, very basics of machine learning and like how to get you started into that field. Then in the in-depth knowledge comes later when we, have some in-person sessions. जहाँ पे I can show you hands-on कैसे project build करते हैं, how image processing और कोई भी specified field हो गया, computer vision, deep learning. So that part comes in later. We first try to implement the basic ML. Then the all the fun part comes in later. अभी तो formulas है, थोड़े बहुत diagrams है, that's it. ठीक है? So thank you guys for joining. You may leave the session if you don't have any doubt. Thank you.
भैया